Great to join you again for our next video. Today I'm going to speak about the resistance temperature detector, or what you and I would commonly know as the RTD. Be very careful to assume that any device that looks like that in your store is indeed going to be an RTD. They often will be mounted in the same housing, but thermocouples may look very, very similar. So please do be exceptionally careful to ensure that you are going to take the right device. As far as the range is concerned, I like to use these devices anywhere from minus 200 degrees Celsius up to 600 degrees Celsius. I don't like to go much more than 600 degrees Celsius because you do find that the platinum electrode tends to break down, and that could give you inaccurate readings. Now, I've just gone and spoken about the platinum electrode, and I'd like to show it to you. The actual sensing element is to be seen on the left-hand side of your screen. So that is going to be the platinum element, which we're often going to be using for the exact measurement. This is the most accurate of the temperature measurements that we can encounter. We are provided with lookup tables, which will make it so much easier for us to go and determine what temperature we are working with. For example, if I was to say to you something such as 27 degrees Celsius, you can go to the table and you have a look at 20 and you move all the way across until you get to the 7. So in this case, the value that we are looking at is going to have an equivalent resistance of 110.51 ohms. If you are working out in the field, this is the most accurate way to go and do any form of calibration or checking of your equipment. There is a simple method that we can go and use, which is handy out in the field, but not as accurate as this. This is my more simplified method. In essence, what we're going to say is that the resistance of the RTD is going to be the resistance of the RTD at 0 degrees Celsius, and that is going to be 100 ohms. Often we talk about an RTD or a PT100. The PT stands for platinum, and the PT100 says that it's going to have a resistance of 100 ohms at 0 degrees Celsius. And that's why I have gone and put in that value of 100 that you can see, plus 0.385 multiplied by the temperature out in the field. Let's go and use that same value of 27 degrees. Now, the temperature coefficient of a PT100 is 0.00385. And if you manipulate that into another formula that I have got, you've got the value of 0.385 that comes in, which makes it 100 ohms plus, and I need to grab a calculator here quickly, 0.385 times 27, and that is going to give me plus 10.395 ohms, which is a total resistance of 110.395 ohms. That's good enough for any work that you and I are going to go and do in the field, but it's not as accurate as your lookup table. And I'm going to go back to the table and put in my 110.395 ohms. And there you can see a comparison of both. At the top of the page, 110.51 is the most accurate, and my quick little formula would have given us 110.395. So ever slight difference, but good enough when you are going to be doing some field work. What if you were to have a negative temperature? It doesn't make a difference. The mathematics is going to stay exactly the same. For example, let's go and say that we are going to work with a value of minus 50 degrees Celsius. The resistance is going to be the resistance of the RTD at 0 degrees, which is 100 plus 0.385 multiplied by negative 50. Now, mathematically, that says to us that's the same as 100 minus 0.385 times 50, which is going to be 100 minus whatever that's going to be. 0.385 times 50 gives me a value of 19.25, and that would then give me a final resistance of 80.75 ohms. So the mathematics is still going to hold true. You just do it exactly as you would, and you shouldn't encounter any problems whatsoever. When you decide to purchase an RTD, you would have to go and make a decision of whether you're going to have a 2-wire, a 3-wire, or a 4-wire system. Now, what they look like is as follows. When you purchase a 2-wire system, it has got the temperature measuring detection at the end, and it brings out 2 wires to you. A 3-wire system is going to have 2 of the wires joined together, and you would have the 3rd wire that comes in. And a 4-wire system is going to give you 4 wires that come back, and between these 4 wires we are going to have the temperature measuring device. Which one to go and use? Well, if you're working purely with simple temperatures over short distances, you can go and use the 2-wire. We often say that that is going to be best for HVAC applications, heating, ventilation, and air conditioning. The one in the middle is what you and I should be using for industrial applications. Whenever you have to do a measurement, or I have to do a measurement, we're typically going to go for a 3-wire system, because that is automatically going to compensate for the lead resistance. And if you do one of my courses, I will do all of the calculations to show you exactly how it is going to fit together. The very last one is going to be for scientific applications. If you need to have very, very high accuracy results, then you would go for a 4-wire system. Practically, you and I will most of the time go for a 3-wire system. A question that is often asked is whether we can put RTDs in parallel to get a better average reading. Now, basic mathematics says that we can't go and do that. If I was to take an RTD, and let's go and say that that's going to be resistance 1, that's going to have a value of 110 ohms, and put it in parallel with another RTD, we call that RTD2 or resistance 2, and that's also going to be 110 ohms. Resistance parallel is calculated as R1 times R2 over R1 plus R2. Now, if you do go and do that calculation, you're going to end up with 55 ohms, which is half of the value that you wanted to go and start off with. So it becomes very cost ineffective to put RTDs in parallel, because I'll have to go and use 4. The first one and the second one in parallel with another 2 in series. That becomes number 1, that's number 2, that's number 3, and that's number 4. These 2 together would give me 220 ohms, and those 2 together would give me 220 ohms. And when I put 220 in parallel with 220, only then am I going to get back to the 110. So it certainly is not going to be cost effective to go and put RTDs in parallel with each other. Again, I have to say that the RTD is the most accurate temperature measurement which you and I can take. And that does wrap up our short video on RTDs. Please do go to my website if you'd like to see a lot more courses that we can present.